We talked about solving linear systems with graphing, and this is going to be the first of two different solutions or two different methods that we can use without graphing. So this one is called substitution, okay? And really what you're doing here is you're just kind of plugging in a value um, into the equation. So it's kind of like here we have y is equal to 5, okay? We also have 3x plus y is equal to negative 16. Now, it's kind of like doing an input-output table, right? In this case, we're saying, okay, well, if y is equal to 5, let's plug that in here for y, okay? So let's rewrite it, 3x plus, okay, 5. I like to put it in parentheses a lot of times so that I don't forget that if there's a negative or if I'm subtracting, then I subtract the negative, because that's a common mistake. Okay, 3x plus 5 is equal to negative 16. Okay, I substituted in, right? I know that y is 5, so where I see y, put in 5. So 3x plus 5 equals negative 16. And now what I can do is I can just go ahead and solve this. So let's go ahead and what I'm going to do is I'm going to add a negative 5 or subtract 5 from both sides. I could have also moved the 5 to the other side and it becomes negative. These cancel out. I get 3x is equal to negative 16 and negative 5 make negative 21. Divide by 3 on each side, and I'm left with x is equal to negative 7. Okay, and we also know that y is equal to 5. So let's go ahead and plug both of these in, or substitute in both values for x and y into that original equation, right? So I have 3x plus y equals negative 16. So I'm going to do 3 times whatever x is plus whatever y is and see if it equals negative 16. Well, I know that x is negative 7. Okay? Negative 7. And y is 5, right? This one came over here. So 3 times negative 7 is negative 21 plus 5. Does that equal negative 16? And yes, it does. So negative 16 is negative 16. Both sides are equal to each other. They're saying the same thing. There's my solution. Okay. So if I were to graph this, the two lines would intersect at negative 7, comma 5. All right, just another way of doing it. Well, let's take a look at one that's maybe a little bit more complicated. Okay, now we have not just a number that y is equal to, but we have a whole set of things that y is equal to. But the idea is exactly the same. We know that y is equal to this thing, so we're going to plug it in for wherever you see y. So I'm going to rewrite. I'm going to x plus 2, okay, and then I'm going to put parentheses, and I'm going to put in whatever y is, okay. Well, this is what y is, so that's going to go inside the parentheses, and then this is going to be equal to 11. Okay. Well, now what I need to do is now I have to use the distributive property. So I'm going to say x plus, and I do 2 times 3x, so that's going to be 6x, and then 2 times 2 is 4, and we'll make that equal to 11. Well, now let's simplify, and so I have x and 6x together make 7x plus 4 is equal to 11. I'm going to subtract 4 from both sides, and I get 7x is equal to 7. Divide by 7. Hopefully you already saw that x is going to be equal to 1. All right. Now, let's go ahead and plug this back in. Now, we're going to plug x in. We're going to solve, right? We're going to figure out what x is. Now, we use this equation already, so I'm going to use the other equation just to make sure. Plus, it's already set up to solve for y, right? So we can do y is equal to 3x plus 2. Well, I know that x is 1, so we'll do 3 times 1 plus 2. Y is equal to be 3 plus 2, so y is equal to 5. Okay, so we have x is 1 and we have y is 5. Let's go ahead and check both of these. Okay, so first I'm going to say 5, is that equal to 3 times 1 plus 2? Well, 3 times 1 is 3 plus 2. 3 plus 2 is 5. That one works. Okay, let's try the other one. So I'm going to do x. So we're going to do 1 plus 2 times 5. Does that equal 11? Well, 1 plus 10, that does equal 11. So that one works too. So my solution is x is 1, y is 5. If I were to graph this, both of these lines, you would see that would intersect at 1, comma 5. Okay, why don't you go ahead. Here's another one for you. I didn't solve it for x or y, so you're going to probably want to make it look like x equals or y equals so that you can substitute it in. Go ahead and try doing this one on your own. Go. All right. Well, if you got stuck right away, one of the things you might want to do is, in order to do substitution, you have to have either x equals something or y equals something so that you can plug it in, right? So I could say x equals something, put it in here. If I know what y is, whatever y will be equal, I can put it in here. Well, this one looks like it's not too bad to change, okay? So I could do x minus y equals 3, and what I'll do is I'll take the y and move it to the other side, so I get x equals y plus 3. Okay, now I know what x is, so I can take this here and I can put it in here. So we'll do that. 2 times whatever x is, so x is y plus 3 plus y is equal to negative 6. Okay, so let's go ahead and we'll do 2 times y, 2y plus 2 times 3 is 6 plus y is equal to negative 6. Combine our like terms, so 2y plus y is 3y plus 6 is equal to negative 6. We'll subtract 6 from both sides. These cancel out. Negative 6 and negative 6 make negative 12. Divide by 3. Y is equal to negative 4. Okay. Well, now let's take this and let's plug it into my other equation. Now, I'm not going to use this. I'm going to use my original equation here, okay? X minus y. So I'll do x minus, well, I know y is negative 4, and this is where putting those parentheses comes in handy, right? Because I do x minus and then whatever y is and plug it in, okay, is equal to 3. So I get x, well, subtracting a negative is the same as adding a positive, is equal to 3. Subtract 4 from both sides, and I get x is equal to negative 1. Okay, so let's go ahead and check our answer here. So I'm going to do, we'll do that first one. So I'm going to do negative 1 minus negative 4. Does that equal 3? Well, negative 1 plus 4 equals 3. Yep, that works. Then we'll try the other one. 2 times negative 1 plus negative 4. Does that equal negative 6? Okay, well, 2 times, that's negative 2 plus negative 4. Does that equal negative 6? Yep, so both of them work. If I were to graph this, the solution would be at negative 1, comma, negative 4. Okay, so hopefully you have a general idea of how to do this. We'll do more practice on Monday when you come to class. Okay, make sure you bring your notes. I'm going to check those, and we will, yeah, have a nice weekend.